7.3 geometric distribution. So sometimes we have a situation that you have to wait until the success event happen. For example, in some board games, you cannot move forward until you roll a specific number, which could take several tries, right? And manufacturer of the products such as switches, relays, and hard drives need to know how many operations their product can perform before failing. In some sport competition, the winner is the player who scored the most points before missing shot. So there is a waiting time or the waiting period. Okay, let's just go to an example. So calculate the probability distribution for getting out of the jet in a monopoly. So here before we did an example that if the person ruling doubles, it can get out of the jail in that game. So you know that if you have two dice, what is the probability of you have double? Let's say 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, right? 6 event out of 36 event. 6 over 30 is probability of getting out of jail. P of success is 1 over 6. And what is a failure? 1 minus 1 over 6, which is 5 over 6. Now, let's say you don't have to, the waiting time is 0. The first time you roll it, it becomes double. So the probability of that is going to be 1 over 6. Just pay attention. The X here is a waiting time. The waiting time here is 0, means you don't need to wait. Right away, you will have double, and the probability of that is 1 over 6. X equal to 1 means you have the first time you roll it, you fail. And then your second time, you have a success. So X is the waiting time. So the first time as you failing, the probability of failing is 5 over 6. And the next trial, you win. You have double, which is 1 over 6. 2 means the first 2 is failing, means 5 over 6 multiplied by 5 over 6, and then success happened, multiplied by 1 over 6, and so on. We take on 3, 4. So you can find these probabilities, and then you can graph it. On the x-axis, you have a weighting, and on y-axis, you have a probability of that. As you see, this is exponentials, look like exponential. So this is geometry probability. So expectation value we know is x multiplied by px for each trial that we have 0 multiplied by probability of that, 1 multiplied by probability of that, and so on. We add up. Of course, this continue for ever, but we know that is greater than 1.3. Now, here is the probability in geometric distribution. This is the formula. Q power x multiplied by p. Q is a probability of success. X is your waiting time or waiting period or waiting trial before the success happen. And Q is the failure, probability of failure. X is the waiting trial, and P is the success, probability of the successful. So expectation, we know this formula is x multiplied by px, add them all, but you can do it much more compact them. So expectation for specific for geometric distribution is q over p, probability of the failure over probability of success. Look at this question. Use the formula for expectation geometry distribution to evaluate the accuracy of estimating example 1. So Q in example that we did, the failure was 5 over 6 and P was 1 over 6. If you do that, that would be 5. Of course, that would be more accurate. Now, this question, Jamal has success rate of 68% for scoring on free thrown basketball. What is expected waiting time before he misses the basket for on a free? So I want to find the expected value. Expected value is Q over P. So Q, we have it. P is just 1 minus Q. okay, be careful that. What expected waiting time before misses means the misses gonna be your P, right? Because you have a waiting until the success happen. So this will be your Q then. So we have Q, the probability of the failure, and the success happening. So P is going to be 1 minus 0.68. So P is 0.32. So Q over P, so we'll give you 2.1. Traffic management. Okay, suppose that an intersection you pass on your way to school has a traffic light that's green for 40 seconds and then amber for 60 seconds. What's the probability that the light will be green when you reach the intersection at least once a week? So success is when it is green. So P is when it is green. Now total time is going to be 40 plus 60, right? 40 plus 60 is 100. Probability of success 40 seconds after that is green. So 40 over 100 will be the probability of success or green. And Q going to be 1 minus 0.4, which is 0.6. Now, if you want to do it using geometry, said what's the probability that at least once a week. So if this is once a week, means the first time you reach the light, it is green. So what is the probability? Have 0.4. But it might be on the first day, it could be red, and then would be the next day would be green. It's going to be 0.6, 0.4. Or the first 2 days will be red, but on the third day, you will have green. So 0.6 power 2 or 0.4. It could be on the first, second, and third, you could have red, but on the fourth day, you could have a green. Or here on the first, second, third, and fourth day, it's green, means 0.6 power 4 multiplied by then the fifth day is green. These are, you add them up, the probability is 0.9 because it said at least once a day, right? The probability of the light being green when you reach the restriction at least once a week is 0.92. What's the expected number? Of course, it's going to be Q over P. Q is 0.6, P is 0.4, is 1.5. Okay, you do the even questions and submit your work to teacher.